Welcome, developers, to The Explainer. Today, we're going to reframe prompt engineering. We're moving it away from just a conversational art and into what it really is when you're building real products, a serious, repeatable engineering discipline. So, here's our game plan. We'll start by looking at prompts as the new code, then we'll dissect the anatomy of a good prompt. We'll cover the foundational toolkit and some really advanced reasoning patterns. And then we'll get into the nitty-gritty of engineering for production, all leading up to the essential mindset you need to succeed. All right, first up, prompts as the new code. We have to change our mindset here. Let's start treating our prompts not just as simple questions, but as true software development artifacts.
Yeah, this quote really hits the nail on the head. For us as developers, prompts aren't just casual chatter. They are a form of programming. You've got to think of them as the API contract you have with the LLM. It's the design spec that dictates behavior. And if you get that spec wrong, your whole system can fall apart.
Okay, so if we're saying prompts are code, then they've got to have some kind of syntax, right? Let's break down the anatomy of a well-structured prompt and its core components.
So, any really solid production-ready prompt has these 4 key ingredients. First, the instruction. That's your action verb, the specific task you want the model to do. Then you have the context, which is any outside info or constraints the model needs to do its job right. Third, the examples. This is huge. It's how you show the model the exact pattern you want back, something we call few-shot learning. And finally, the output format. This is where you tell the model how to give you the data, like in a JSON object or a simple list. They're basically like arguments in a function call, all working together to get you a precise, predictable result.
All right, we've got the anatomy down. Now let's start building out our standard library, These are the foundational, high-impact techniques that you're going to find yourself using over and over again. Check this out. This slide is fascinating because it shows just how big a difference a little technique can make. On the left, you've got zero-shot prompting. We just give the model an instruction. Classify this, but we don't give it any examples. And look, it gets it wrong, calling the review neutral. But then on the right, we use few-shot prompting. Same instruction, but this time we provide a couple of examples of what good looks like. And bam, it correctly identifies the sentiment as negative. It just goes to show how critical providing examples is for dialing in the accuracy.
Now this one, role prompting, is an absolute game changer. It's so powerful because you're essentially putting guardrails on the model. Instead of it being this general know-it-all machine, you make it a specialist. You say something like, act as a senior security reviewer, or you are a travel guide specializing in Southeast Asia. That simple instruction dramatically changes the tone, the style, and the expertise of the output, making it way more targeted and useful for what you're trying to build.
Okay, the basic stuff is great, and it'll get you pretty far. But for the really complex problems, the stuff that needs actual logic, we have to go deeper. We need to teach the model how to think. So let's unlock some of these more advanced reasoning patterns.
So you throw this classic logic puzzle at an LLM with a simple prompt, and what happens? It usually flunks it. And you might wonder why. Well, it's because it's not actually reasoning. It's just pattern matching. It sees the numbers 3 times, and 20, and it just mashes them together without any logic, giving you a totally bizarre answer.
And here, right here, is where you see the magic of a technique called chain of thought. Just look at the difference. The simple prompt on the left gets it spectacularly wrong, 60 years old. But on the right, we added just 5 little words. Let's think step by step. That one tiny phrase forces the model to slow down and show its work, to externalize its reasoning process, just like we would. It correctly figures out the age difference and lands on the right answer, 26.
It's so beautifully simple, right? All you do is tack on a phrase like, let's think step by step. And just like that, you're turning this black box into a glass box. You can actually see the model's logic as it works toward the conclusion. This trick alone can dramatically boost performance on anything that requires real reasoning, from math and logic puzzles to writing complex code.
All right, this is all great in theory. But now for the million-dollar question every developer has. How do we actually ship this? How do we make this stuff reliable, scalable, and machine-readable enough for a real production app?
I think we've all felt this pain. The single biggest headache when you're trying to integrate an LLM is that its raw output is usually just a big, unstructured blob of text. It's unpredictable and an absolute nightmare to parse. If your app's logic relies on trying to pluck data out of a paragraph, your whole app is built on a house of cards. We need structured data. And this, right here, is the solution. It's a total game changer. By explicitly telling the model to give you the answer back in JSON format, you completely solve the parsing problem. You get clean, predictable, machine-readable output every time. This makes integrating with your back-end, your database, or your front-end components so much simpler. You're no longer just hoping for a good response, you are engineering one.
Now, to get even more reliability, we can use a clever technique called self-consistency. The idea is really simple. Think of it like this. You ask a whole team of experts to solve the same problem, but you tell them to think about it in slightly different ways. You do this by running the same prompt multiple times, but tweaking a setting called temperature to get different reasoning paths. Then you just take a majority vote. The most common answer is probably the right one.
And does it work? Oh yeah, the numbers don't lie. Research shows that layering self-consistency on top of chain of thought gives you a huge accuracy boost, almost 18% on really tough arithmetic problems. That's a massive improvement from a pretty simple technique, and it can make your production app significantly more robust.
Okay, so let's zoom out and bring this all home. What are the big principles here? What's the mindset you need to have to really be a prompt engineer? Ultimately, it all boils down to this. Treat your prompts with the same respect you gave your production code. Design with simplicity. If a prompt is confusing to you, it's definitely confusing to the model. Be specific about the output format you need. Demand that JSON. Use clear action verbs to kick off your instructions. And most importantly, remember that this is an iterative process. You have to experiment, test, and refine. And you have to adapt because the models are always changing, and a great prompt today might need a tweak tomorrow.
And this all brings us to the big question for the future, right? As these AI models get smarter and smarter, is what we just talked about, this detailed, hands-on prompt engineering, the future of how we all build software? Or is it just a temporary bridge, a skill we're learning on the way to something even more advanced? By mastering these techniques right now, you're not just learning a new trick, you're positioning yourself at the absolute forefront of this new engineering paradigm. That's all for this explainer.